I'm Anil Kumar. As a pilot project, I'm starting a new series for students taking calculus in grade 12 or first year university. We'll also include students who are taking IB Math grade 11 because they start calculus in grade 11. You may subscribe and include email ID to participate actively and get future updates. All my videos are and will be free on YouTube. Now the idea here is that students taking calculus sometimes need extra help. I'm ready to provide you with that. But I want to restrict the group to, let us say, 15 students. You'll be encouraged to post your questions and I'll, within 48 hours, answer them in details so that you understand all the concepts. Now to begin with, what I'm doing here is sharing with you some previous test papers. Test papers always help us to prepare better. So this one is of an IB student. You can actually copy these questions, work them out. I'll take some of them in this series also. Here's the next one, correct? So let me see the other side of this test paper. So we have two more questions here. Basically, this one is on rate of change and instantaneous rate of change. Now, these are very important topics. And in diagnostic test, we always see such questions. Now, here's another test paper where you may have to find equation of the function given or possible zeros, or this is also instantaneous rate of change. Now, these test papers are for the students taking calculus, and immediately in the very first week there will be a diagnostic test, right? So this is all you should know before starting calculus. That's the whole idea, right? So let's take another one. Here are a few more questions. Rationalization is a huge topic. You should be fairly good at it. Then of course you have seen rate of change is another very important topic for you to understand before getting into calculus. Now here are a few questions on functions. So rational functions, piecewise functions, to sketch functions, right? So, and then here is another test paper. This is all from the very first quiz or test where they are trying to figure out what you understand even before starting calculus, right? Rationalization is a very important topic. And of course, rate of change, instantaneous rate of change. Now the last question here is actually very difficult and a very good question. So I'd like you to make a note of these questions. You can go back and forth, copy these questions and do them even before the semester starts for calculus. So in this new series, I'm going to start with the diagnostic test. From the previous test papers, I've made my own questions, which I'm going to answer one by one in this particular series. So I have a set of 15 questions. Here are first 4. You can always pause the video, copy them out. And then we have the next 4. Right? And then question number 9 to 12. So these are based on functions. And then we have 3 questions based on rate of change, right? So I hope you have copied them all. You should try them out. Take this as a diagnostic test. Now let's begin answering them one by one. So here's the very first one. Question number 1 is, a linear function is given by y equals to 5 minus 3x. If x increases by 4, how much does y change? Well, this is the simplest question in the series. We have y equals to 5 minus 3x, which is a linear equation. Now it says, if x increases by 4, how much does y change, right? This question is based on simple context, simple formula, but still it is tricky. So when you're doing calculus, you have to think a bit. Now here, we are saying if x increases by 4, how much does y change? So basically, we are given change in x, which is, let's say, delta x, is 4. We need to find what delta y is. And as you know, slope, which is rate of change, normally you write m in the equation y equals to mx plus b, gives you ratio of this, right? So m is change in y over change in x. Now from the given equation, you know the slope is minus 3. So you could always write this as minus 3 equals to change in y over change in x, which is given as 4. Now if you cross multiply, you get minus 3 times 4 equals to change in y. So minus 12 is the change in y. Do you get an idea, right? So you can say that how much does y change? Y change by minus 12. So that's our answer. So y decreases by 12, or you can say changes by minus 12. You get an idea, right? So that is how you can answer this question. So it may look simple but interesting, correct? So let's move on to question number 2. Now let's do question number 2. It is to simplify 2 plus h whole cube minus 8 over h. You can always pause the video, answer the question, and then look into my suggestions. Now let me rewrite this particular expression. We are given 2 plus h whole cube minus 8 over h, right? Now I could write this as 2 plus h whole cube minus 2 cube, right? Whole cube minus 2 cube over h. Now I hope you remember the formula. What is a cube minus b cube equals to? A cube minus b cube is a minus b times a square plus ab plus b square, correct? If you have a cube plus b cube, then we get a plus sign here and a negative sign there. Now in this particular case, we have to use difference of cubes, where a is 2 plus h and b is 2. So if we apply the formula, what do we get? So we get the first factor as 2 plus h minus 2, and the other factor as square of 2 plus h. Now we use minus, we'll use plus here. Product of these two, that means 2 times 2 plus h plus 2 square. That's what we get, correct? So let's expand it over h, of course. So let's expand it. So we have simplified this one. So we have only h here times 2 plus h whole square, where let me write this as, I could write 4 better, okay. 2 square plus 4h plus h square plus 2 times 2, 4 plus 2h plus 4, correct? Over h, over this h. So they cancel away. So what you see here is that this h in the denominator cancels off. And whatever is there in this numerator, you can simplify this, correct? So 4 plus 4 plus 4 is 12. So we get 12. Let's open the bracket. Then as far as h is concerned, 4h plus 2h is 6h. And then we have the term h squared. So that is what we get. So normally in calculus and also in rate of change, you must have seen this kind of formula which is applied for rate of change. And at times we assume that h is very, very small as compared to 1. So if you neglect this value, we get 12 as our result. Now it has a lot of significance in calculus, which we will learn as we move forward, right? So I hope the concept is very clear, a straight application of difference of cube formula. Now let's take up the next question, which is rationalization. So now you have to rationalize numerator. We are given square root of 5x plus h minus square root of 5x over h. So let's rewrite this first. Square root of 5x plus h minus square root of 5x over h. Now, rationalization really means to multiply and divide by its conjugate. And what is the conjugate? Conjugate, we have to just change the sign and multiply. The whole idea is that a plus b times a minus b is what? Is a square minus b square. So when you square root, you get something without radical. So that helps you to simplify. So that's the idea. So you simplify many expressions involving radical signs by rationalization. So that's a very important technique to learn. So the numerator will be difference of squares. So you get 5x plus h minus 5x. And in the denominator, I'm sorry, I wrote it wrong. It should have been 5x plus h square root plus square root of 5x. I'm sorry. You have to multiply and divide by the same thing. So it is multiplying by 1. So what you get here is h times, let me write within square root, I'm within square brackets, square root of 5x plus h plus square root of 5x. Now the numerator, 5x and 5x cancel. We get h over h times square root of 5x plus h plus square root of 5x. Now h and h cancels. So what you get here is 1 over square root of 5x plus h plus square root of 5x. Now rationalization really helps. You can see in the given expression, if I say that h approaches 0, then what do we get? We get something like this, that the numerator, which is 5x plus h minus square root of 5x over h, approaches 0 over 0, which is undefined, correct? However, if in this expression I use the term x approaches 0, h approaches 0, then what do we get? We get this expression as equals to 1 over twice square root of 5x. Do you get an idea, right? So that really helps us to simplify our expression and also find some values when we are approaching, that means some value. So it will have a great significance in calculus, and that is the reason why I have taken this up as question number 3, and it is also a test question in many diagnostic test papers. So let's move on further. Here is question number 4, simple factoring. Factor 3 times x to the power of 3 over 2 plus 6 times x to the power of half minus 9 times x to the power of minus half. Let me rewrite this. You need to factor 3 x to the power of 3 by 2 plus 6 x to the power of half minus 9 x to the power of minus half. Do you see that? You need to factor this one. Now, it may be difficult for some students since we are using radical signs here. So in factoring, you haven't really done such question up to now. Well, let's first group factor 3 itself because 3 is a common factor. Now what should we factor from x? If you see the powers of x, minus half is the lowest power. So we could factor minus half, correct? So as far as numbers are concerned, 3 divided by 3 is 1. Now what should I get here? It should be x to the power of 3 by 2 minus whatever this power is, which is minus half. Do you see that? So it gets added up. Okay. Now the next term is 6 divided by 3 is 2. X to the power of half minus half, correct? And the last term will be 9 divided by 3 is 3. X to the power of minus half, which we actually factored out, but let me write minus half, correct? This is what you get. Now let's do our math. So we have 3 x to the power of minus half within brackets. What is 3 by 2? Let me rewrite this. 3 by 2 plus half. Do you see that? Plus 2x half plus half minus 3x to the power of minus half plus half, correct? So we get 3x to the power of minus half. Now, 3 by 2 plus half is x to the power of 4 by 2 plus 2 times x to the power of half plus half is just 1 minus 3x to the power of minus half plus half is 0. Now, when you say 3 to the power of x minus 2, you could have written this also as 3 over square root x. Is that okay? Minus means 1 over x and square root. Now here, what do we get? 4 divided by 2 is 2, so you get x squared. In this case, it is 2x. Anything to the power of 0 is 1. You get minus 3. Now that is a quadratic expression. You could always factor this one. What you get? You get 3 over square root x times. We are looking for product of minus 3, correct? So we need two numbers whose product is minus 3 and whose sum is plus 2. Well, 3 and 1 will work. So, but 3 should be positive. We need plus 2 as their sum and minus 1. So that is how you could factor the given expression. So I hope all the steps are absolutely clear. Now in calculus, we have to really work with radicals. So you should be good at factoring such radicals, right? Now let's take one more before I close the part 1 of my video. Then I'll do part 2 and 3 to take the rest of the questions, right? So here the question is, determine possible zeros for the function f of x equals to x cubed plus 3x squared minus 4. Now, let me remind you of remainder theorem, if you know that. Or even factor theorem, both are related. Well, you must have learned in polynomials, correct? So when you're looking for zeros for a polynomial, I've taken a very simple example, just x cubed. It could be to the power of 4 or 5, all right? So to factor this, we look for possible factors. Possible factors are factors of the constant here, which is 4. So the possible factors could be plus minus 1, plus minus 2, or plus minus 4. Now, if 1 is a factor, that means if I divide by x minus 1, the remainder is 0, right? Factor theorem says that you find the value of the function for a given number, and if the remainder is 0, remainder is the value of the function. If the remainder is 0, then it is a factor. So let's substitute 1 here. So if I substitute 1, I get 1 cubed plus 3 times 1 square minus 4, and that is 1 plus 3 minus 4, which is indeed 0, correct? So that means x minus 1 is a factor. Now since x minus 1 is a factor, I could do long division. So I could do a long division here, dividing x cubed plus 3x squared. Since we do not have x term, we'll write 0x minus 4 by x minus 1. So if I do that, well, let's divide by x squared times. We get x cubed minus x squared. I hope you remember the division. Okay, so it gives me 4x squared plus 0x. Now I could multiply by 4x. So that gives me 4x squared minus 4x. When you take away, you get 4x minus 4, and that goes 4 times. And therefore, I could write the given expression. Let me rewrite f of x as equals to x cubed plus 3x squared minus 4 as equal to x minus 1 times the quadratic function x squared plus 4x plus 4. You get an idea, right? So we have factored the given expression. Now this can also be factored. You know, it's a quadratic equation. It's a perfect square. So we could write this as x minus 1 times x plus 2 whole square. Do you see that? So that's easy, kind of, not so difficult. Anyway, so we got this factored, but the idea is to remember factor theorem to factor polynomials, right? Well, if you try what is f of minus 2, you should get 0, right? If I write minus 2 here, you do get 0. So that's the other factor. So that is how you should be factoring polynomials, and that's a technique which you should always remember, right? So I'll stop here now and I'll take up these questions in part 2. So once you are ready with part 1, move on to part 2 and do rest of the questions. I hope you like this idea, and I'll again emphasize on your actively participating. If you really want to take my help on this topic, feel free to send me emails, right? And so here is the sheet which we began with. So you can always send me emails requesting questions. You could also write down your comments, any questions you have, as a part of comment in this particular video, and let's see if it really helps. All the best. Thanks for watching.